Welcome back. So we're going to continue. In the previous video, we talked about molarity and percent by mass, and it was our first Unit 2 video going over the study guide. So we're now going to get into the ideas of solubility. In solubility, we split up into two skills. We kind of conceptual understanding, and then specifically a skill on being able to analyze and read and get data and information from a solubility graph. So we'll start here. So solubility measures the maximum amount of solute that can dissolve in a given amount of solvent. And so solubility, it's the maximum. And so if a solution has dissolved less than the maximum amount, then we call that an unsaturated solution. And if it has dissolved the maximum amount, like it's met its solubility, then it's considered a saturated solution. Think about a sponge that's absorbed so much water that it can't anymore. You would call that a saturated vessel. And so in this case, if it's dissolved as much as it can, it's called saturated. And so if more than the maximum has been added to the solution, like you added way too much sugar to your coffee, then only the maximum amount is going to be able to dissolve, and the rest is going to sit undissolved at the bottom of our the container. So we know that if you add sugar to your coffee, eventually you reach a point where no matter how much you stir and no matter that your coffee is really warm and hot, it's not going to dissolve and the sugar just sits at the bottom. And so we can look at it in a couple of different ways. So if we look at question 1, it says Jorge is trying to create two different types of solutions. In beaker A and beaker B, there is water that already contains 10 grams of salt. Okay, so I like to draw things out when I have it. Okay, so we've got beaker A and beaker B, and it's got some water in it, so I'm going to use this is my water, and they've already dissolved 10 grams of salt. So we have 10 grams of salt in each of these. Okay, good to know. So that's what we have. And it says he adds 20 grams to beaker A. Okay, so 20 grams gets added in there, and it all dissolves. But he adds 30 grams to beaker B, and only some of it dissolves. So that means there's some just kind of floating or sinking to the bottom here, not dissolved. And he wants to know, okay, how should he label the type of solution? Well, we know that if there's some undissolved, remember, that means it's dissolved the maximum. And so that means this is a saturated solution. Okay, this is B would be a saturated solution because there is some sitting undissolved. Whereas beaker A is probably unsaturated. It all dissolved. It's possible he dissolved exactly the right amount, but we know for sure that it has a good chance of being unsaturated. Because it was able to dissolve. So if we want to put this in a sentence, we could say beaker A is unsaturated because it all dissolved. And you could do the same thing for beaker B. You know, beaker B is saturated because not all of it dissolved. Some of it is undissolved. It already dissolved the maximum. And so we can also look at it maybe with numbers and not really like a picture. So it says the solubility of a mystery solid is 45 grams per 100 milliliters of water. So that means if I have 100 milliliters, I can dissolve 45 grams. This is my maximum. Label each of the following solutions as either unsaturated, meaning less than the max, or saturated, meaning it's dissolved the max, and determine the amount of solute that will not dissolve. Okay? And it tells you, not all solutions will have some that way. So if we look at A, for example, it says that there are 35 grams of the mystery solid. Well, since that's less than 45, which is our maximum, that means this is unsaturated, and it will all dissolve. Okay, but if we look at B, 45 grams, that is our maximum. So that is considered a saturated solution, but because it's not more than that, it will also all dissolve, which it's kind of hard to fit that here. But if we look at C, C is 55 grams. Well, that's more than the maximum. And so that is still saturated because the 45 grams will dissolve, but it means that there will be 10 grams that's not dissolved, okay, because 55 minus the 45 grams, which is the maximum, means that you're going to have 10 grams left over that just kind of sits at the bottom. And I'm going to let you go ahead and do D, E, and F on your own. If you want me to check your work, you can either comment, leave a comment under the video, or you can ask me in class. So if we look at the graph, it's basically going to take this same thing. And so solubility can be plotted on a graph of, well, solubility, which is going to be your solubility. Spelling is important, guys. Solubility on our y-axis versus temperature in degrees Celsius on our x-axis. And the cool thing is that when we see all of these chemicals in the graph, all the lines that are sloping upward tell us that the solute is a solid when it was dissolved in the water. But if it slopes downward, that tells us it's a gas, because temperature affects solids and gases differently when we're talking about dissolving. And so each line represents the solubility or the maximum amount that can dissolve at that particular temperature. And so if a solution is created with less than the maximum, it's unsaturated. And if it has the max amount at the line or more than the line, it is saturated. Now, you might be saying, Ms. Nichols, what do you mean about being on the line, above the line, below the line? So I'm going to simplify this graph for a moment and give us a fake graph that I'm going to totally make up. But if, for example, we're talking about solubility and we're looking at this line, and let's say we're looking at 50 degrees Celsius, and that this point here is 50 grams, okay? So that point, 50 grams of whatever solute at 50 degrees Celsius is saturated. That is the maximum amount, okay? So that means if at the exact same temperature, I only have, let's say, 25 grams at 50 degrees Celsius. It's under the curve, like it's under this point. And so that helps us remember that it's an unsaturated solution. So under the curve, unsaturated. But what if instead of 25 or 50, what if I try to dissolve, let's say that's 75 grams at, let's do 80 grams instead. Let's say that's 80 grams at 50 degrees Celsius. Well, the maximum was 50. So that's still a saturated solution, but what that means is that 80 grams minus 50 grams gives us 30 grams that will be undissolved, kind of sitting at the bottom of the beaker or the cup or whatever it is. And so that's kind of the key things that we want to understand about these graphs as we look into these questions. And so question 1 says, what is the solubility of KNO3, which is that green line, at 50 degrees Celsius? Now remember, when you see the word solubility, I want you to think that's the maximum, and that is on the line. And we've got our temperature, 50 degrees Celsius. So if we look, KNO3 is this green line here, which I meant to highlight, not go over with a red thing. So that's that. And 50 degrees Celsius is right here, which when I zoom in, it gets kind of blurry. So solubility is a line. So at 50 degrees, that's this point. So you just kind of go all the way over to see how many grams that is. It's a little above 85, like it's more than 80, less than 90, a little more than halfway. So let's say 88 grams. If you were to say anywhere from 85 to 89, that would be considered correct. So there's not really a way for me to be like, no, 87 is incorrect. This is kind of an estimate with this graph, but 88 grams of KNO3 would be the solubility at that temperature. And it changes if you change the temperature. Now, question 2 says, how many grams are required to create a saturated solution of ammonia at 10 degrees Celsius? And again, remember, saturated, that also means the maximum. So you want to think the line. And we're looking at 10 degrees Celsius. So ammonia is this blue line here. And we're at 10 degrees Celsius. So if we go up to where that meets the blue line, it's right here, kind of above 70, but really close. So I'm just going to guess and say, I don't know, 71 grams, right? Not quite 70, but so 71 grams of NH3 are required to be saturated. That's the maximum amount at 10 degrees. And so if we look at question 3, it says how many grams of NaCl need to be added to a solution that already contains 10 grams dissolved in order to create a saturated solution. So remember, saturated is maximum, and there's already 10. Now, the thing about this question is there was a typo. I didn't tell you a temperature. So let's just say at 80 degrees Celsius. We're going to make it up. So if we look at NaCl, which is this light blue line right here. And again, let's highlight it. Okay, we're looking at 80 degrees Celsius. And if we go up to the line, that's a little under 40. So let's say 38. So if we say that the maximum is 38, so if the maximum is 38 grams, they want to know how many grams need to be added to the solution because it already has 10. So 38 minus 10 grams will give us 28 grams of NaCl needed. So you're just kind of manipulating the numbers to find your answer. And then the fourth question says how many grams of KClO3 or potassium chlorate will remain undissolved. So here we're wanting to know what is undissolved if 20 grams are added at 20 degrees Celsius. So if we look at 20 degrees Celsius, that's right here, KClO3 is this purple line. So the maximum is, very low at that temperature. It's about 5 grams. So what they're asking is they want to know how much is undissolved. Because if the maximum is 5 grams and they added 20 grams to it, it means only 5 grams will dissolve. So 20 grams minus 5 is equal to 15 grams of potassium chlorate undissolved, right? That's a lot that's going to be sitting not dissolved at the bottom of the container. So hopefully you understand solubility a little more, and the graphs. Highly recommend if you missed something, going back, rewinding, slowing down the video if you need to. And we will go into the rate of dissolving and how things dissolve through solvation and dissociation in the next video.